Yeah, welcome back, everyone. Today we shall be going through the commercialization of this project, which is large vision models for mild disease retinal screening in Ugandan healthcare. So our potential target customers, we have ophthalmologists, NGOs, like like site savers. Then we have Ugandan Ministry of Health and the national referral hospitals like Mulago. Then we also have regional referral hospitals and large private hospitals, plus private clinics being our potential target clients. So we go through a demo of the application when it is lively hosted and how it operates, uh, the phone and the web platform coming with such a solution. So we see high prevalence of eye diseases, including diabetic retinopathy, glaucoma, and hypertensive retinopathy, and more other eye diseases. We explore the core problem being the limited access to ophthalmologists, having limited specialized screening equipment, uh, really in rural areas. So we experience like who experience this challenge most, like patients living in rural areas. Then we see why AI is essential, how it provides content-based reasoning and decision of certain AI disease infections, and the way how it lowers the retinal scan diagnosis time. And we explore the measurable impact, which is the reduced time spent on each patient during diagnosis rendering. So we explore the main stakeholders and and users and of the system. We explore the primary users, secondary stakeholders, and we see the different roles they play in the ecosystem. We also explore the governance entities, and we see how they interact to enforce compliance. So we explore the data sources that vary. So our data set consists of over 3,000 images, of which we are able to have over 45 disease classifications. And uh, here we explore the sources, the data types, take into consideration the processing pipeline. Then we put into consideration ethical and legal frameworks, how we are able to enforce compliance with national data protection policies, how we are able to obtain informed questions from users. Then we also look at how we are able to add value mechanisms by utilizing the knowledge base as our backbone during training. Then we look at the solution we are providing. Uh, why the AI algorithms being used. We are utilizing four model architectures, of which we have graph crypt transformers. Then we have visual language graph neural networks, scene graph transformer, and vision graph neural net for training. And lately we adapted graph crypt model architecture for our final deployment. Then we explore the model inputs and outputs, and we also see how our system is able to generate decisions and insights. Uh, and we're able to give confidence score, and we see how models are able to reach inference or prediction. So continuing with solutions, we are able to integrate user workflows into the existing systems. We integrate seamlessly into clinical and research workflows via web interface. Then we are also able to have mobile-based employment via edge devices. Those are mobile phones for offline screening, rural clinics. Then we are able to provide responsible AI by embedding responsible AI mechanisms such as explainability, bias control, and data privacy. So we explore the key performance metrics that were used for evaluation. We're able to explore accuracy, latency, throughput. Also, we look at user-centric metrics. We look at adoption rate amongst others, and we are able to come up with high usability and trust among our key partners, including clinicians. So This is how we are able to ensure uh, uh, ethical concerns, fairness, and interoperability, bias mitigation, transparency. And we have also business metrics, including customer churning and customer acquisition cost, amongst others. So we look at the unfair advantage, what makes us different from the rest. So our system deploys optimized scene graph transformer-based model that is really fine-tuned for retinal disease detection using hierarchical attention and regional reasoning. So we are able to have feedback loops, which really strengthen our product over time by enforcing continuous learning mechanisms. And we have in-place infrastructure for sustaining long-term distinction. So uh, so we are able to offer offline deployment via Flutter app application, and we have a web-based platform which can scale to hospital networks and mobile screening devices with great internet activity. So we look through the channels and distribution of our system. We see, yeah, acquisition channels. We are partnering with MakeLab. Also, that is Makerere. Then our deliverable channels. We are offering a free web interface API that can be accessed by doctors with a free API endpoint. And we are partnering with Makerere University Hospital, me also with MakeLab at the same time. Then this is how we are strategizing to retain our tactics by enforcing continuous updates and more module training via retina scans from around the world. So these are our revenue streams. We have direct revenue models like subscription, license fees, and pay-per-use APIs. Then we have also indirect revenue models, data as a service, consulting services, and ecosystem partnerships. Then we also look at value-added streams, direct one-to-one sell-off, and so on in most developing countries. So these are the key resources we are utilizing and amongst of which we have financial resources, data infrastructure, plus technical infrastructure in place. Then these were the key activities, model life cycle activities, operational activities, customer focused activities, providing technical support, community building, user feedback loops, amongst others. So strategically, these are our key partners, technology partners, including cloud service providers like Hugging Face. Then we have ethical oversight partners, those are regulatory agencies and ethical boards, then and also accessibility councils. We also have distribution partners, telecom companies, and digital hubs, plus fintech platforms, and amongst others. So this is the host infrastructure that will help us realize this dream, turning it into reality, not just ideas in space. So the cost will cost over 200 M Uganda shillings. Then we also have costs engaging in computing infrastructure costs, then compliance and legal costs, then also marketing and distribution costs, maintenance and scaling costs. So now here we come to how we are able to ensure governance, ethics, and compliance. Then governance model, our model is being oversighted by MICLab, currently, then and also Dr. Garuwanga Navin to meet the intended expectations. Then we integrated in explainability tools. Then we have legal and ethical frameworks. We also put into consideration accountability. Then we are able to ensure fairness and bias auditing via regional model benchmarking and comparisons with other models. So when it comes to scalability and sustainability, we are utilizing Docker and Kubernetes for deployment while adapting to microservices architecture and modular pipelines. Then we are ensuring continuous learning through our GitHub flows. Then locally, right now, when it comes to localization, we are rightly supporting English now. Then in terms of financial sustainability, we have revenue reinvestments, partnerships, grants. We are able to have impact investment. Then we take into also consideration of environmental responsibility. Our model really generates less carbon footprint. No, we are not contributing much carbon uh, during during inferences. Uh, so it's really environmentally friendly. So the intellectual property, yeah, we have custom AI algorithms and model architecture, data processing pipelines. Yeah, and also we have system integration frameworks. Yeah, this will really ease the operations of medical people and the whole industry to large. So these are the table contributions. Thank you for listening.